Good morning, everybody. My name is Terry Adamson. I am the Technical Director with Fenestration Canada, and this is our first education session of the Spring Conference. We've got several sessions over the next 2 days, so check out your schedule and please try to get in and participate and join us for some, what we hope is some really great education to help you guys understand some of the challenges that we're all facing. First off, mute your cell phones, please. I also want to take the opportunity to thank our sponsors. Without our sponsors, truly, we're not here, of course, as well as members. But our sponsors really step up, and they really stepped up this year. It's amazing what we've got for sponsorship. So I want to take the opportunity to run through them as well. So Sherwin-Williams, Pella, Professional Home Builders Institute, PHBI is our education sponsor for the conference, so we're really grateful for them stepping up for that. Elton, Novatech, Guardian Glass, JSA Machinery, Screenco, Tremco, FCI, Federated Insurance, Caldwell Interlock, ESS Software, Open Janela, Quanex, Amesbury Truth, Plaspro, Ultrafab, Pref ERP, ODL, Trimlight, Leighton Consulting, Lux Windows. Is there anybody from Lux in the room? Lux is celebrating 50 years this year, and that is one impressive feat for a window company. So thanks for being here, guys. We really appreciate it. DeKunik, Marvin, PH Tech, Furco, Fenestration Review, and New Coat. So again, thanks to our sponsors. Without them, we would have many more challenges than we have. That's a great segue to this first session. So the first session today is with Scott Williams. Scott Williams is with the BC Government, BC Building and Safety Standards Branch, Ministry of Housing. Scott's primary focus is on the development and successful implementation of the BC Energy Step Code and the transition to net zero energy ready buildings and zero carbon new construction. Scott's got over 12 years of experience as a building enclosure engineer. Scott brings strong technical background and passion for green building design, the development of policies and technical regulations relating to building performance in the BC Step Code. Before Scott starts, I would just want to say one thing. The government of BC has been a great partner with Fenestration Canada. They're very open with what they're doing. They invite us in to have conversations. We have a standing meeting with them every month that we get together and just talk about what's going on. So we really appreciate what the Building Safety Standards Branch is doing in BC and their openness to work with our industry. So welcome, Scott.
Great, thanks so much, Terry. Before I start, everyone can hear me okay? Yeah, great. So thanks very much. Thanks for having me. It's a pleasure to be here, at least virtually. So I just wanted to go over a few things with regards to the Energy Step Code, which is regulation within BC as per the BC Building Code. Give a little bit of history and kind of where things are going in terms of its trajectory. So in terms of the Building Safety Standards Branch, of which I am a member, we set and administer the BC Building Code. And so I was the main technical lead for a lot of the most recent changes to the BC Step Code, as well as the Zero Carbon Step Code. So I'm basically going to be providing a little bit of historical context in terms of policy perspective and inception, as well as past and present step code requirements. So I'm not going to dwell too much on the past, but we'll definitely provide a little bit of context with regards to that trajectory in terms of where we are currently. So way back when, prior to the Energy Step Code, local governments requested, or encouraged builders to build more efficient buildings using a range of programs. So while working towards greater energy efficiency, but each one in a different way and with a different focus. So this created a lot of problems for industry to build capacity over time, as well as it created quite a bit of confusion from jurisdiction to jurisdiction in terms of what was actually required. And so you'll see on the right there, there's a number of logos of a number of the different standards or requirements that were at the time being required by different local governments. So really a patchwork quilt of requirements for industry to navigate. So what the Energy Step Code does do is it provides local governments with the ability to ask for energy efficiency beyond the code in a consistent way. So for industry, the Energy Step Code allows them to build capacity with confidence about where local governments and the BC Building Code are headed over the long term. So there's some degree of variation within the Energy Step Code, given the different steps within the Step Code that can be required by any given local government. However, the key is that there is a consistent methodology regardless of the step chosen. Further, as we move towards more stringent baseline requirements, this will promote further harmonization, and I'll get into that a little bit more as I go through the slides. So, adopted in 2015, the Building Act established a new structure for the regulation of buildings in British Columbia with three main objectives. Improve the consistency of building regulations in BC, improve the competency of those building and inspecting buildings, and support for innovation in the construction sector. To improve consistency of building regulations, the Building Act established the province as the sole authority for technical building requirements. Any local government bylaws or other enactments that establish technical building requirements were unenforceable as of December 15th, 2017. So this essentially eliminated the patchwork quilt of different green building requirements by the various local governments. So to resolve any potential issues, the Building and Safety Standards Branch engaged local government, industry, utilities, and other stakeholders to develop a single technical standard that could be enforced under the Building Act, and so was born the BC Energy Step Code. So around the same time as well too as the Building Act, when it came into force and effect, there's also announcements from the BC government through the Climate Leadership Plan, which looked at net zero energy ready buildings by 2032. They referred to them back then as being stretch codes, but with that ultimate goal of 2032 and net zero energy ready construction. So as of April 2017, the STEP code was signed into regulation, initially as an opt-in, where local governments had the ability to choose whether or not they wanted to participate and to what level of stringency. Much simpler and stripped down than what is currently in the STEP code. Still had the thermal energy demand intensity, still had mechanical energy use intensity and total energy use intensities. And I'll get into that a little bit more in some further slides. It also had the reference building approach as well too, which some of you may be familiar with through the national code system. It was a little bit less refined in terms of climate zones. So for part 9, we had less specifics with regards to climate zones. And in part 3, we really had no climate zones in terms of the representation of what was required in terms of the outcomes with thermal energy demand and total energy use. So what the STEP code is essentially a big shift from the status quo, as this is a performance-based requirement as opposed to a prescriptive-based code. So most people were used to relying on those prescriptive-based requirements and basically being told what needs to be installed when. So the performance path is a dramatic shift from that, in that it provides the latitude of the builders and designers to really do what works best for their project, with the ultimate end goal of meeting the metrics that are required within the Energy Step Code. So fundamentally, there's energy modeling that's being undertaken to understand the theoretical performance of the building. Air tightness testing is a requirement to determine how this building is actually performing in situ in terms of that air leakage component. And like I said, there's no prescriptive requirements. So a really big change, and really provided that avenue for innovative design. So essentially, what is the STEP code? I'll go through a couple slides that provide those basic concepts, and then we can get into kind of the nuts and bolts and some details with regards to some of the most recent changes that we have within the BC Building Code. So the Energy Step Code really focuses primarily on that building envelope first approach. So really making sure that primarily the building envelope is constructed in a manner so that it has a high thermal efficiency, so that it reduces those loads and then essentially reduces the capacity or requirements for the actual mechanical and electrical systems that are used to provide that space conditioning and ventilation in domestic hot water. So with regards to the building envelope, really we're looking at reducing that thermal energy demand, which is really accounted for via solar gains, internal gains, and all losses associated with the thermal performance of the building envelope, including losses via thermal bridging, insulation values, air leakage, as well as ventilation losses. So normalized over the modeled floor area, this equates to the thermal energy demand intensity, or TEDI, and this is one of the key metrics within the Energy Step Code. And then we look at total energy use. So what are the base systems that are being used within the building? So we have heat, domestic hot water, we have ventilation. And then in terms of the part 3 world, we're also looking at process and plug loads that are also included within that total energy use metric. So in December of 2018, the province released its Clean BC strategy, which reaffirmed the net zero energy ready target and established new interim deadlines. With the first deadline in 2022, when new buildings must perform 20% better than those built to the requirements of the 2018 BC Building Code. So in the context of the national code system, British Columbia, around that same time, signed the Construction Codes Reconciliation Agreement under the Canada Free Trade Agreement. So this agreement supports the harmonization of building, plumbing, fire, and other construction codes across Canada. Harmonizing construction codes or removing differing requirements between construction codes helps to decrease construction costs and reduce barriers related to manufacturing, operation, inspection, education, and training. So through this harmonization process, so through Clean BC, we announced that we were reaffirmed that commitment with regards to net zero energy ready by 2032. We also provided a roadmap on how to actually get there. And at the same time too, we had that commitment with regards to the harmonization with the national code system and trying to eliminate as many variations as possible between the BC Building Code and the National Building Code system. So I'll go into that in a little bit more detail in a little bit in some further slides. So here is the roadmap that was provided essentially within the Clean BC commitments. So you'll see the number of different steps here, and this pertains to Part 9 construction, and how we have that increased stringency in terms of performance, moving from Step 1 to Step 5. And then also too, you'll see that we have those interim dates in terms of 2022, 2027 and 2032 in terms of what those increased baseline requirements would be. So I will note as well too, this was the first regulated roadmap to net zero energy ready in North America. So upon its original inception, it was opt-in and opt-in only. And so within a couple of years, we really started to see a lot of uptake of the Energy Step Code across local governments. So a lot of local governments who had already had green building requirements in place really quickly jumped on to the regulation and selected the steps that worked best for them in terms of what worked well for industry. And their commitments as well too. So in 2019, there was approximately 39 communities that had jumped on in terms of opt-in. And then in August of 2021, we have 52 communities. And then at the end of 2022, there was approximately 60 communities that had opted in. And then there's a number of other communities that were actually in the consultation process as well too. So a resounding success, given the fact that this was an optional regulation, and it seemed that really there's quite a bit of uptake, and which represented a fairly significant amount of the actual new construction that was going on in BC. So here we are right now. We're at the 2022, which has kind of come and gone. As of May 1st of 2023, the requirements of that 20% better did come into effect within the BC Building Code. So this essentially means that for Part 9 residential buildings, we're looking at Step 3 as being the new base code requirement. And then for Part 3 buildings, we're looking at Step 2 requirements. So I'll go through in some detail some of the key changes with regards to the BC Energy Step Code. I will go through both Part 3 and Part 9. And we'll go, obviously there'll be some focus on how this impacts fenestration. So within Part 3, we now reference NECB 2020. And like I said earlier in the previous slide, Step 2 in terms of the Part 3 context is required for all the occupancies currently listed within the Step Code. So those are essentially C, D, and E occupancies, so residential, business, and personal service, and mercantile. And so that performance path is now the new base code minimum for those occupancies. We also do have some A and B type occupancies that are listed within the Step Code, but these are inherently more complex in terms of the energy profiles and energy usage, looking at hospitals, care facilities, and these essentially at this point in time, we don't have intensity metrics for those, but what we do have is a requirement to follow Part 8 of NECB 2020. There's some slight tweaks that I just want to make you aware of with regards to our office and commercial occupancies. They do have slightly more stringent total energy use intensity metrics. The result of this is as a result of the fact that NECB 2020 did make some significant changes with regards to energy performance. So we just wanted to make sure that that Step 2 requirement was in line with NECB 2020 and was matching or better than as opposed to less than. So we wanted to make sure that we're shifting the dial that way. The thermal energy demand intensity still remains unchanged. ASHRAE 90.1 2019 and NECB 2020 can be used for any other occupancy that's not currently listed within the Step Code. So that means you have the traditional paths that you're probably all familiar with regards to the prescriptive, the trade-off, or the performance within ASHRAE 90.1 or NECB. There's one additional air tightness testing standard that we have, and that's just in line with what is currently within the National Building Code. So we just basically wanted to make sure, again, due to our harmonization commitments, make sure that that was being matched within the BC Building Code. And one thing I wanted to mention as well too is that within Part 3 and the Energy Step Code, we do reference the City of Vancouver Energy Modeling Guidelines. So when this is to be used in conjunction with NECB, and one thing that to note is that in terms of fenestration, there is that requirement for NFRC 100 testing to determine the thermal performance of window assemblies. But one thing that they do have is that they want this to be representative of all of the windows that are being installed for any given project. So this essentially means that this has created some confusion in the industry as to what this actually means. So in some instances, modeling and testing is being conducted for all window sizes in a project, which has obvious implications with regards to time and cost. It's also not very clear in some instances in the contract documents what is to be undertaken in terms of that modeling and testing. Different methodologies are being used with regards to there's an area weighted average compliance path that can be used or worst case scenario compliance path that can be used. Again, there's no calculation methodology that clearly outlines what that actually looks like in the City of Vancouver Energy Modeling Guidelines. And then there's the ultimate discussion about who is actually responsible for all of this. So we have been engaging the City of Vancouver with regards to this in our discussions with Fenestration Canada. We will be having some ongoing meetings to see what we can potentially do to fill those gaps to provide that clarity. And just so that you know as well too, is the City of Vancouver is currently going through the revision process for the energy modeling guidelines, so they're keenly aware of this issue, and so that we're hoping this is something that gets absorbed and addressed in the next version of the energy modeling guidelines. So within part 9, you'll see that there's a lot of very similar language to what's currently within the National Building Code 2020. Fundamentally, like I said earlier, that performance path of step 3 is required for all part 9 residential buildings. However, there is a caveat here that there is a 20% better prescriptive approach. But one thing about this is that it needs to be adopted by the local authority in order for this to come into force and effect. So essentially, this would need to be written into their bylaws, whether or not they're complying or pursuing this path of that 20% better prescriptive approach. So, so as a voluntary alternative to the performance requirements of the STEP code, a local authority may establish a bylaw allowing for buildings within the scope of the Part 9 STEP code to comply with the prescriptive requirements in 936.2 and 936.4 of the BC Building Code. This may be necessary in jurisdictions where access to energy modeling and airtightness testing services is limited or impractical. Where a local authority chooses to allow for compliance with the prescriptive requirements, they may not restrict builders from voluntarily complying with the performance requirements of Step 3, Step 4, or Step 5 as an acceptable alternative to the prescriptive requirements. However, like I said, acceptance of the prescriptive requirements for Part 9 STEP code buildings must be stated in bylaw. So in terms of the performance path for Part 9, just a couple things in terms of the way the code language has been laid out. There's some slight changes from what you've been used to. We have broken out those percent better than metrics from the intensity metrics. So you'll see that there's 2 different tables. There's now, in keeping with our harmonization commitments with the national code system, there is some relaxations for buildings that are less than 300 meters cubed in terms of interior volume. So this plays nice with smaller buildings that are inherently more energy efficient and providing those relaxations for those buildings. There's also additional air tightness testing metrics, so normalized leakage rate and normalized leakage area, in addition to the air change requirements that are currently listed within the BC STEP code. This allows, again, provides a little bit more leniency for smaller buildings because ACH doesn't necessarily play nice with smaller buildings all the time. So these are additional metrics that can be used to demonstrate compliance. Another thing to note as well too is that there is an exemption for log homes. We didn't feel through the research that we had done that log homes would be are well versed to meet that step 3 requirement in terms of the performance path. So they essentially revert back to the pre-existing requirements for Part 9 residential in terms of the prescriptive trade-off, or if they like, they can follow the performance path as well too. So regarding the prescriptive path, like I said earlier, the performance path is a default unless the prescriptive path has been adopted by a local authority via bylaw. One thing to note is that these prescriptive requirements do require fundamentally a heat pump or a heat recovery ventilator in terms of the systems. So that, and then after that, you can start to look at the improved thermal efficiencies that are outlined within this new prescriptive path. Again, similar to the performance path, this only applies to Part 9 residential construction. Regarding the adoption of the prescriptive path, it's really kind of tough to say which local authorities are going to be adopting. Some remote communities have expressed interest. However, it's kind of unclear at this point who will be adopting, so we should know fairly soon. The prescriptive path option is meant to be in line with the Step 3 performance path in terms of that 20% improvement. And at this stage, there's no intention of having prescriptive paths for Step 4 and Step 5. This was really meant to be a stopgap measure for this significant change to the step 3 performance path. And there are a number of local authorities that don't necessarily have the capacity, the infrastructure, or the knowledge with regards to the performance pass. We wanted to provide a little bit of leniency there, so that's why it's currently within the step code. However, we'll have to revisit this as we move to the more increased stringency with regards to steps 4 and 5, and we'll see where we land with that in terms of the uptake, in terms of the performance path, and whether or not there is that capacity out there. One thing I will note is that this is a BC variation from the National Building Code. The National Building Code, if you've seen, has a points-based approach for that prescriptive option. So there's still quite a bit of development that's going on, a lot of discussion with regards to how this is ultimately going to look in the National Building Code. So we decided at this point that we would have our sort of a made in BC prescriptive path, and we'll see where that sort of lines up with the National Building Code as the National Building Code continues to go through further development. So, in terms of fenestration, this is the table taken from the BC Building Code in terms of those increased thermal performance values for fenestration. So you will see that it has a U value of 1.22 across the board. And you'll also notice as well too that the table only references fenestration and not fenestration indoors, as shown in the pre-existing prescriptive requirements. So table A, as opposed to table B. So when following this prescriptive path, these requirements apply to windows only, and does not apply to sliding glass doors nor swing doors with glazing. So that is one caveat with this. You would actually revert back to the pre-existing requirements as a result. And then also to note as well too is then within the BC Building Code, we still have those variations, those allowances for swing doors in terms of the reduced thermal performance. So there are those exceptions that still lie within the BC Building Code with regards to swing doors in terms of the climate zone that you're located in and the number of doors, and then also outlines a range of thermal performance from a U value of 2.0 to a U value of 2.1. And then there's also one exception as well too with non-conforming doors. If there's only one, then it can have a U value of 2.6. So a couple key differences from the BC Building Code in terms of the Energy Step Code and the National Building Code and NECB. So the STEP code has minimum mandatory performance requirements for energy efficiency for most occupancies. So in part 9, we're dealing with residential occupancies only. So that's C type occupancies. For part 3, we're looking at C, D, and E type occupancies. Whole building air tightness testing is a requirement, whereas the National Building Code is not. It is an option. For part 9, we have a combination of intensity metrics, so the thermal energy demand intensity and total energy use intensity, or mechanical energy use intensity, as well as the percent better than. And then within the National Building Code, they just have that reference building approach, that percent better than. For part 3, within the NECB, there is the tiered approach that outlines that percent better than, again, that reference building approach. We have not adopted that at this time, and we have only intensity metrics with regards to part 3. And another key variation as well too is that we do reference ASHRAE 90.1 2019. And so like I said earlier, any occupancy that falls outside of the occupancies listed within the STEP code with regards to part 3, the ASHRAE 90.1 compliance path is something that can be used. So with regards to our harmonization commitments, why do we have these significant sort of variations at this time? Like I said earlier, we're really trying to reduce those variations as much as possible, but there's still some development that is going on in terms of the energy efficiency aspects of the National Building Code. So they do have that reference building approach that is consistent across part 9 and part 3. However, there is the process that they're going through with regards to the development of intensity metrics, which would closely align with what we currently have within the Energy Step Code. So we're in keeping with what we've done in the past with the Energy Step Code. Those remain as is. We will see where this national code development goes in terms of where those intensity metrics, how they get developed, and what they actually end up being. And then we will make the decision about moving forward in terms of that harmonization and meeting those harmonization commitments. So right now you will see some of those variations, but through that harmonization commitment, you will see some changes in terms of more closely aligning with the National Building Code. So one key thing that I wanted to highlight as well too is that there's been some really consistent questions and concerns with regards to solar heat gain coefficients for windows and how this is represented within the performance path. So within the performance path, it's really up to the designer, owner, builder to figure out what works best for their project. So there is no requirement for a solar heat gain coefficient in terms of that range. So there is the ability to take advantage of a higher solar heat gain coefficient during the winter months to improve that thermal energy demand intensity. So it can be a positive from that side. But when you look at the summer months, that can be a problem, obviously, as a result of increased solar heat gain and the potential for overheating. So with the performance path, there's a lot of latitude as to where you can actually land in terms of that solar heat gain coefficient, and we wanted to provide that avenue to make the correct decisions. However, that overheating aspect and that safety aspect obviously is a concern. Within the proposed code language for the BC Building Code in the next version of the code, which is actually currently available for comment, we have proposed cooling requirements within the BC Building Code. So what we have proposed is to have a indoor design temperature of not more than 26 degrees Celsius in at least one living space in each dwelling unit. So this applies to both Part 3 and to Part 9. So what this does do is this is in response to the coroner's report as a result of the tragic events of the heat dome that we experienced in June of 2021. And the recommendation to have within the BC Building Code active cooling requirements as well as passive cooling requirements. So in terms of that passive side, we in terms of Part 3, we still do have the ASHRAE 55 analysis that's to be done via the City of Vancouver Energy Modeling Guidelines. So that does help to drive that passive aspect. As well too is that if you want to reduce your loads in terms of your systems that you're going to be installing to meet that 26 degrees Celsius, obviously there's some work that needs to be done in terms of optimization there as well too, in terms of reducing those loads as well. Further to that, there's further work that's being done, and now that we have cooling, we're proposing cooling within the BC Building Code. Now what can we do to focus on those passive measures? So that's the next step in this. Now that we have the cooling requirements, now it's about really starting to focus on those passive requirements. So what does that look like? We're working with National to see where that actually lands, and we're hoping to have some developments fairly soon on that. So that's it in a nutshell in terms of past and present. So thanks very much, and open the floor to questions.
Okay, thanks, Scott. Questions for Scott? I knew Anton's hand would go up first.
You mentioned the performance path is default, and we've been working through this now in BC and providing product into homes. Overheating is a significant consequence of some of the early days of this step code. The challenge we're faced with is energy advisors have been using high heat gain as a solution, design solution. And with energy advisors in high demand, the training is fairly quick, my understanding. It's a 1-week course. Is there any consideration to create some professional liability constraints within the code, such as architects and engineers, to provide letters of assurance? So, for example, let's say 26 degrees is not achieved in a building after year 1 of being built. Who is liable for that? What's the responsibility to the design team to make sure that that can get corrected and be dealt with? BC went through a leaky condo crisis. 20 years ago, and one of its best defense mechanisms was liability focus from architects and engineers. And my concern is that there's nobody regulating energy advisors. And I just had a job last week where the only solution they decided on was a zero 0.4 or higher solar heat gain solution. And the building's funded by CMHC to be step 4. So just looking at the liability side of things, about how do we protect our industry, and thinking of like the possible use of letters of assurance and taking accountability for the designs that they're doing.
Yeah, thanks. Yeah, obviously a real concern. With regards to the EAs fundamentally are there to essentially administer the Energuide rating system, right? And so, where does their responsibility start and end with regards to input in terms of the design? That gets really challenging. Ultimately it's up to the builder and owner to make sure that the BC Building Code is being met. The EA is providing that input, but understanding that with the BC Energy Step Code, they do have more of a active role in terms of what is actually being implemented and designed. This is an ongoing discussion that we're having within BC. This is an unregulated industry, as you've suggested. And so what can be done in terms of providing more education so that not only the EA, but all parties involved in any given design is aware of the issues that can arise as a result of making certain design decisions. So there's a lot of work that's being done through partners such as BC Housing in terms of providing additional clarification and education. There's the mandatory training that has just come out from BC Housing that it consists of 8 modules that does touch on these sorts of issues. So it's looking at this in terms of more of the integrated design process as opposed to just looking at the EA specifically. Understanding that, yes, there are some liability issues here, especially if an EA is maybe taking on more than they should be responsible for. But this is something that we're actively looking at in BC and hoping to find some solutions.
Thanks, Scott. Anybody else? So, Scott, the 26 degrees that has to be maintained in a living space, is that the room can never go over 26 degrees, or is there a time frame that it has to stay at that, or what's the parameters around that?
So that's the design temperature. So using, say, in the Part 9 world, we're looking at F280 as being the means and methods of determining whether or not that 26 degrees is being exceeded at any given time. So there's not a time limit. It's just whether or not it's being exceeded, looking at this as a design temperature, right? So the design temperature is going to take into account the building holistically, what that ambient value is in terms of that July 2.5% dry value for that given geographic location. And then the systems will be designed accordingly in order to meet that design temperature, and reducing that risk of that 26 degrees ever being exceeded.
Okay, thanks.
Hi there. Do you have or is there a list maintained of municipalities which are opting for the prescriptive path versus the performance path? Is there any kind of register, or do we kind of have to just pick through the weeds for that?
Yeah, it's at this stage, no, we don't. There's some work that's being done by the local government peer network to try and collate a list. But I think until that happens, only my real advice to you is just in any local government, if you're doing any work there, make those inquiries to ensure that you're following the requirements that have been set out by that local government. So perform your due diligence. The thing is that what we found with the step code, we did something very similar in terms of providing that list of local governments that had adopted the step code. Where it started to get complicated was that there were some changes within bylaws as they continued to work through the process in terms of changing what step. And so for us to keep up with that, became fairly problematic. We weren't necessarily being informed. And so that list wasn't necessarily comprehensive. And so we're always suggesting, well, as a result, yeah, you can look at the list as a reference to get an indication, but reach out to that local government, understand what is listed within their bylaws, and then design accordingly.
Thanks. Scott, I still wrestle with the windows, sliding doors, and swing doors having different requirements. The sliding doors used to be included, if I'm not mistaken, and I'm wondering what the rationale was for giving them, quote unquote, an exemption compared to windows.
Yeah, I think it was really as we're going through the public review process for the proposed code changes. There were some concerns raised by members of the door industry that this was going to be problematic in terms of meeting that 1.22. And so simply we removed that door designation from those requirements. And from that, we pulled out all doors essentially as a result. So very somewhat blunt. Is this something that we can look at? Yes, this is something we can potentially look at to see how we can refine it. But at the same time, like I said, this is really meant as a stopgap measure for this initial rollout of step 3 as the baseline performance requirement. And so we're not really looking to have this for future steps. So this may be somewhat short-lived. So we'll have to see how this actually sort of evolves and transpires.
Okay, so jurisdiction going prescriptive path, windows are 122. Swing doors, if I'm not mistaken, would be 1.8, which is what they used to be with some exemptions like you noted as per climate zones. What are the sliding doors at then under a prescriptive path?
So they would follow the pre-existing prescriptive requirements. So it would be one, if you're in climate zone 4, that'd be the 1.84.
Okay, thanks.
And then also,
Go ahead.
sorry, just one thing I wanted to clarify as well too is that there is the energy efficiency standards regulation as well too that does regulate point of sale. So they have a U value requirement of 1.61, which does encompass sliding glass doors as well too for Part 9 residential. So you know, even if you wanted to design something that was less stringent, when you go to buy it, you may have some issues with actually getting that lesser performing assembly.
Thanks. Any other questions for Scott? All right, Scott, thank you very much. Appreciate your time, and we'll be chatting soon.
Great. Well, thanks for having me.